Hello and welcome to the video. This is the second video in my VTOL series. Don't start here, there's a link down below to the others in the series. Go and have a look at the first one that explains about some of the basics and considerations and why in this series we're using things like Pixhawk and some of the stuff that Ben's about to show you. This video series has been shot with the kind support and help from Ben up at 3DXR, part of 3DXR's business, as well as selling lots of motors, flight controllers, props, ESCs and all the gubbins that we use. The other part is he builds large custom UAV systems for agriculture, mapping, surveying and all kinds of different things. And he's built literally dozens and dozens and dozens of VTOL vertical takeoff and landing craft. So he is an expert and he has very kindly agreed to put aside a little bit of time to kind of show us the process that he goes through to get to the end in order for everything to work. Because although VTOL looks relatively simple on paper, it's a plane and a quadcopter kind of smooshed together, it's things like the transitions that can be incredibly difficult. Now, if you've never done anything with Ardu Pilot before, this isn't the place to start. There is my Pixhawk 2020 series. I've got one for plane and one for quadcopter. I'd go and recommend you watch the one for plane. The link is down below. Once you've watched that, come back to this, because this is building on top of that kind of knowledge and know-how. Now, time codes are down below, but in this video, Ben's going to go through some of the basics, talk about some of the setup things in Mission Planner, flash flight controller, go through setting up the CANBus stuff, and also enabling and setting up the outputs. The aim at the end of this video is to get to the point where it's ready to install into the model. So in the next video, we can go through all the commissioning tips that he uses to kind of commission it on the bench to make sure that it's all working okay. As with any Ardu Pilot build, I would strongly recommend, if you are thinking about doing this, go and have a read of the documentation. Documentation is fantastic. It is very detailed. The challenge with Quadplane at the moment as part of the Ardu Pilot family is it is not point and click in the interface. There's lots of setting of individual parameters, and that's why it's great that Ben is sharing this knowledge with us, because then hopefully once we've got all this out of his head, then I can go away and we can have a go at building this stuff with cheap and cheerful hobby grade components and see how well we can make it work and make sure those transitions work okay so the thing doesn't fall out of the sky. So with all that said, let's go over to Ben on the bench and start setting up the Pixhawk.
Okay, so for this video we're going to show the initial setup and configuration for a 4+1 VTOL. So again, we'd highly recommend that keep it simple on your first ventures into VTOL before you go into the likes of tail sitters and tilt rotors. This 4+1, so it's separate lift and thrust, is a great way to start to experience VTOL, and to be honest, it's my preferred VTOL arrangement. So let's take a look at how we set this up from the beginning. What I've got here, this is a brand new cube out of the box, and first of all we must flash them with firmware. So most flight controllers now don't come with any firmware on them, and what we need to run VTOLs or Quadplane, we're going to start off with Ardu Plane. So in our latest version of Mission Planner, make sure you're always up to date whenever you're doing new builds. It's also advised to do fresh installs of Mission Planner, not update an old version. So let's go to our setup page and install firmware. So this is without the flight controller connected, and it's at this point that I want to connect the flight controller to allow us to update the firmware. In this case, we've heard the USB beep. We've got a solid red light on the cube, which will stay solid, indicating there's no firmware, and it's also detected a board, so it's found a board type here, and we'll see it's an H7. This is now changed and it's saying what board is connected. It doesn't say cube orange, but it tells us it's found an H7 flight controller. This will now allow us to choose the firmware. So in this case, we're seeing at the time of doing this video 4.1.7 is the official, that is referred to the latest stable firmware. So stable releases are what you see here. Now I'll click, it's going to allow us to install it, and it's also going to get us to confirm the board type. In this case, I'm selecting cube orange, and as we can see here, it's going to download Ardu Plane. We'll see the progress here. Downloads it from the internet, erases the board, and now installs the firmware.
So I have one quick question. Because we're building a VTOL, there aren't any VTOL options on this screen. So we start with plane and then we add the VTOL elements on top of it. Is that the way it works?
Absolutely correct, yeah. And it's referred to, what we're going to do is we're going to enable Quadplane or Qplane, and that is the changes to the firmware that allow all these VTOLs to be possible. So we start off with the standard plane firmware, and then we enable the VTOL functionality, which is these Q parameters, which stood for originally Quadplane. All these other pictures are different vehicle types, and to be honest now there is only rover, plane and copter, as well as sub. Okay, so we've had the beep, the board is resorting, and then we will start to see the dual COM ports in this case for a cube orange. So let's check our little drop down here. Okay, we've now identified, after the firmware is installed, we now see dual USB sockets. One of these is for connecting and doing settings, the other one is a CAN pass-through. So let's connect to the board. Okay, so we've connected to the correct COM port. Normally you will see one COM port identified as MAVLink, which is how you normally communicate to do your settings, and another COM port which is referred to as SLCAN, and that is a CAN pass-through, which allows you to adjust the settings on CAN devices. More and more of your peripherals are becoming connected by CAN. As we'll see shortly, we're going to be using a GPS that's CAN and also an airspeed sensor that's CAN. So we'll look into some of that further in the video. Now that we're connected to the flight controller, we can see the HUD, the heads-up display, is responding to movements. We're getting readings, we're getting height. So we're connected to the autopilot as we should. There's a couple of settings we must enable to allow us to use Quadplane to configure our VTOL. So I'm going to head into the configuration tab, the full parameters list, and I'm going to search for Q. And at the moment, Q enable is set to 0 or off. So we must change the value to 1 to enable it. We can tab out of it and write these parameters. Now it's given us a prompt here. This is an enabling parameter, so we must refresh the parameter list or restart for this to take effect. Pay attention here. When I search for Q this time, we only see one Q parameter. After a reboot, we are going to see all the available options for Quadplane. While we're in the screen, I'll also do a couple of parameters that need to be done on first setup. So we must enable the CAN. So we're going to enable the CAN drivers. So I'm turning on the CAN ports 1 and 2 because we will be using CAN devices. I'm also going to remove the safety switch because we're using a GPS without a safety switch. I'm going to tell it we have a CAN GPS when that does get connected. So that's GPS. And I'm going to search for GPS type 1. And the default is automatic. We must tell it is drone CAN. And at this point we must also tell it our airspeed sensor is going to be CAN. So I'm going through these quite fast, but these are a bits of setup that can be done before we do this first reboot. So let's have a look for our airspeed type. The default is one particular common airspeed, but we will be using a CAN airspeed. So let's do as many of these initial settings as we can. These could be done immediately before setting the airspeed, but I'm just doing them at this beginning. Also, because I know we're about to reboot it, it's a good opportunity to set these. So let's do a full reboot now. I'm going to disconnect. Good practice is to, instead of constantly pulling the USB out of the cube, let's take it out of the computer to unpower it. We'll give it a few seconds and then we'll reconnect it, making sure it's done a full reset. And we'll reconnect once it's booted up. There we go. So we're connected to it again. So we have enabled Q parameters. So let's just have a little look at what that's done on our servo outputs. So what we've got here is it's dropped in, as well as the traditional plane settings are aileron, elevator, throttle and rudder. It's also dropped in 4 motors, which you wouldn't normally have in a plane. Let's have a look at these full parameter lists and see what else has changed. So full parameter list, let's search for Q again. Now previously we only saw 1 Q parameter. Now, because we've enabled Quadplane and rebooted it, this is all settings related to quad planes, so anything that starts with a Q. So we've got parameters here that are very similar to multi-rotor parameters, but they have the Q in front. So these affect how the vehicle reacts when it's in a copter mode, so your copter tuning. We've also got quad plane specific, such as quad plane assistance parameters. So what they do is they're sort of stall prevention, where if you are below stall speed as an airplane, it will assist you with the lift motors. And then we have the most important ones here are our frame classes, frame type parameters. So let's have a look in our case here. We've got Q enabled. We've got a frame class here is a quad, exactly what we're using. The frame type is an X. So ours is a standard X configuration, not a plus or a Y. Then we have again some more parameters related to quad functionality. And now let's have a little look at how we're going to assign the servo outputs for this particular build we are doing. So let's just take a look at other options. As we go through the list of quad plane parameters, we'll also see other types of VTOL, such as tail sitter. So again, for your first build, we would recommend starting with the simplest sort of 4+1 setup. But as you progress, here's some of the settings for the current firmware 4.1, where you would make it into a tail sitter. And we also have tilt parameters if you're doing a tilt rotor. This allows you to assign which channels are tiltable, such as your front motors or all of them. So again, adding this Q enable has dropped in another 100 or so parameters, all related to quad plane functionality. These last few at the end here are also, we'll come into these, where we have weather vaning and prop assist. So we'll cover those a bit later in the video. We've just flashed the firmware and adjusted a couple of parameters. What we'll do is we'll do some more of the initial setup for the fighter plane. So this is what we're featuring in this video. And we're going to set the servo outputs. So we're on the setup page, the mandatory hardware and servo outputs. And we're going to set these to the plane, to the fighter. So the fighter is a 4+1 VTOL. In this extremely detailed picture here, we're going to add each control surface into this servo output in the order I do them. So we have the 2 ailerons. On this particular one, we also have 2 servos for elevators. Now, I don't like using Y leads, and we have enough outputs. So my first job here, I'm going to shift our quad motors onto the auxiliary outputs. So I'm going to use auxiliary 1 to 4. Now I know these are actually, the numbering continues on from the main 8. So auxiliary 1 is actually number 9. So on the screen here, I need to tell it this is going to be motor 1. 10 is going to be motor 2. 11 is going to be motor 3. And 12 becomes motor 4. So what I've done there is I have shifted our quad outputs onto auxiliary 4. I must now sort of disable this output. So where they were, this needs to be sort of rebooted. But what that's allowed me to do is shift the motor inputs to a different place. Okay, so we've got as well, we've got an aileron, an elevator, a throttle and a rudder. And because I don't want to use a Y lead, I want to have, I need another elevator, because we have 2 servos on the elevator, and I also need another aileron. Now these are not directional. We don't have a left aileron or a right. It is just and it defined as an aileron. By doing it this way, instead of using a Y lead, if your particular airframe needs some sort of reversal, you can independently reverse each servo. You can also trim your outputs and reduce the minimum and maximum. So if you have the available space to do it this way, I'd strongly recommend you ditch the Y lead and you just give each servo its own servo output. Okay, so let's have a look. We've got 2 ailerons, we've got 2 elevators, we've got our main throttle for our pull motor, and we have our rudder. I've also built this particular airframe as a twin engine on the front, and when I did that I selected a throttle left and a throttle right instead of throttle. So this is a single engine we're doing at the moment, so our front motor, our pull motor, is throttle. And then we should reboot after this stage. We can also, before rebooting, do our accelerometer calibration. So we have a nice level table here. We'll just run through the accelerometer calibration. Okay, so that's us rebooted after the accelerometer calibration. I'm now going to go back to the servo output page, and I just want to check the trim values of the channels we've just selected. So we've got our aileron, it's got the correct default movement, elevator, throttle trim is down to the correct level. So you'll notice there, servos for our control surfaces, the trim value is 1500 in the middle. Our throttle, the trim value should be low. So that looks good, so that's updated. With the motors were previously disabled, and the motors we've added here, 1, 2, 3 and 4 are motors, but look at this, it's sitting at 1000, not the 1100 trim. So that is a parameter we will manually change. If it was a multi-rotor, you would adjust this in the ESC calibration page, but because it's a VTOL, we're going to have to go and manually take care of that. So let's have a look. It's for a quad plane, so it probably starts with a Q, and we're looking for a motor PWM min and max. So let's have a little look. Here we go. Let's check that to 1100. So this is a common area I see people making mistakes on, is all around sort of ESC minimum and maximum values and the calibration on VTOLs. If you get this wrong, what you don't want to happen is you could potentially be losing your maximum thrust, and on a VTOL that could be a huge issue. So my process now with all VTOLs is to calibrate the ESCs manually, normally using a digital servo tester, and I will use 1100 as the minimum, 19 as the max, and I will use my check sheet here and tick off as I've calibrated and set the direction of each motor. So if we write these parameters, and then this will update in the initial setup in the servo screen. So if you hadn't done that, you would have risked the sort of trim value being lower. So we have the nice values here. And the reason we're seeing these numbers here move and jump around, that's just because we're currently in RTL. If that was annoying you, or if you had servos connected and you were getting jitter, you could simply put it into manual mode. And what that'll do is that'll set a neutral value to all your servo outputs. So we'd expect to see here now everything should sit at the 1500. There we go. So that would have stopped any servo jitter on your bench, which is annoying. Okay, a couple of other things for a VTOL that are very important. So we need an airspeed sensor, and we need a GPS and external compass. So for a VTOL to transition properly, it needs it needs to know its airspeed. So the way, let's refer to the transitioning. We have a forward transition where the plane is going from a copter to a plane, and then we have a back transition where it comes back from a plane to a copter. Now this is all related to airspeed. So the forward transition, it is going to keep on its VTOL motors or its quad motors until it's reached the minimum airspeed. Then it adds a delay before shutting them off. So without accurate airspeed readings, you risk a failed transition, transition into the ground, or prolonged use of the VTOL motors. So in this case, what we have here is the Matek DLVR airspeed sensor. This is a CAN device, so we need to get this set up and connected. We also have our CAN GPS here. So let's see if we can get talking to these. This is another area people struggle with. So let's have a look. We'll disconnect and unpower. Whenever you're connecting peripherals to any autopilot, do not add and remove them while it has power, even from USB. So we're going to remove the USB, and let's start with the first device, which is our GPS. And what we're all going to do here, we'll connect them both on the same CAN port. So we can use these handy splitters. So these are available in various forms. So let's go both at the same time. This is the beauty of CAN. And then each one's going to end up with its own address. So at the beginning of the video, after we'd updated the firmware, we were left with two USB ports, two COM ports. One of those is definitely the cube, and the other one is this SL-CAN pass-through. So what we must do now is, because we've connected to CAN 1, we're going to connect to the cube, to the autopilot, and we're going to tell it we want the other USB to pass through to CAN 1. So let's load up again, connecting over Mavlink. We'll go into our full parameter list. So that's configuration. And let's search CAN. And what we're looking for is the C-port pass-through. So let's have a little look here. There we go, CAN, SL-CAN, C-port pass-through. So we must tell it which one we want to talk to. So I've connected both the airspeed sensor and the GPS to CAN 1. So we've set that, and we must reboot. So that's another one of these parameters that only takes effect after reboot. So these are little things you just got to be cautious of. Now, when we want to talk to our CAN devices, we're going to select this additional COM port. So we have been using, in our case, COM14. This number will depend on your computer. Let's have a look. We're going to select COM15. We're only selecting it. We are not pressing connect here. We're going to go into setup, optional hardware, and we're going to click on this drone CAN and UAV CAN. Okay, so now we can see our CAN devices appear as expected. So we have the default number 10 is the autopilot. We have our here, so that's the GPS, and we're getting our Matic airspeed sensor. So everything is appearing as it should be. So let's now connect back to the autopilot, and let's check the functioning of these. So back to the main COM port and connect. For those of you who may realize here what's happening when we connect via Mavlink, we're actually getting this connecting via Mav FTP. So this was a new feature which pulls the parameters much faster. So those of you that have used this for a while may remember the sort of green sliding bar that took 30 seconds to a minute to load. With Mav FTP, you're actually getting a 1 or 2 second download of all the parameters. So great new features. Okay, let's see what we've got here. We've got, because we're indoors, we're not getting a GPS signal. But I know the GPS is working because instead of saying no GPS, it says no fix. So it knows there's a GPS connected. We're just not getting a sufficient signal to get a fix. So I'm happy that that will work if we went outside. Because we don't have a position, our airspeed and our ground speed are sort of wandering together. So if I just give a little blow towards our sensor, there we go, we're seeing a raise in that. If we did have a GPS lock, our ground speed would be fixed, and it would only be the airspeed that would be moving when I blew into it. So that all looks good for our peripherals. Now let's have a little look at a menu that is specifically for Quadplane. So let's head to the configuration page. And what we have on here is our QP extended tuning. So Quadplane extended tuning. And what we're seeing here is the default parameters that can be adjusted maybe before first flight. So I just know that in this case, this flight controller is going to go into a 2.4 meter wingspan VTOL. So there's some parameters I would adjust the same as if it was a large multi-rotor. So for example, up here, these acceleration values, that's how quick it's going to respond to roll and pitch here. So these would be cranked down to probably a third of this value here. We've also got quick access to the PIDs, and then also some other settings on here, such as our speed up and down, as a VTOL, as a quad in this case. There's also a couple of other parameters that are worth considering before you did your first flights. So let's go back to our 4 parameters list in the queue, and I know, for example, on this one, I like to eventually dial down the maximum angle. So let's have a look what our default angle as a quad plane is. So we have our, let's go through some of these parameters. Q angle max. Okay, so this is allowing the quad plane as a copter to go 30 degrees. Now, in the final setup of this particular drone, I limit that to either 10 or 15 degrees. That's because with such a sort of large wingspan, you do not want to throw this plane around. If you're building a smaller quad plane, you might actually want to increase this. The main idea here is there is a lot of adjustment, there's a lot of refinement, and the variety of quad planes or VTOLs you'll produce from, say, sub 1 meter to 5 or 6 meter wingspans will have very different settings that you can tweak to your sort of style of flying and your needs. So these are just a few things I might go in if I know they're significantly different to what I'm expecting. I can tweak these now. Okay, and before we move on to fitting the autopilot into the plane, let's just double check our servo outputs again. And what I'll probably do is write these numbers onto our trusty picture here. So for example, we can label our ailerons with our output numbers such as 1 and 6, and our elevators would be 2 and 5. And what I do is, I know I always try and have my autopilot facing forward. So because we've got, say here, 1 and 6 as an aileron, number 1 is more to the right, so that basically is going to be the right aileron. Number 6 is to the left, so that'll be the left aileron, etc. And then our motors 1, 2, 3 and 4. This is what we've done here. We printed off the handy ArduPilot reference. So 1's the front right, and that must be counterclockwise. 2 becomes the rear left, must be counterclockwise also. So this is why it's handy to maybe produce a little picture as you go along. You can mark down your channel numbers and also tick off as you calibrate and set the direction of each motor.
So a massive thank you again to Ben for going through that and getting us to this point in the series. Again, links down below. Do make sure you are subscribed, have the bell notification icon turned on, and we will continue this series and get to the end and have it flying, and then we can use that knowledge and know-how to then go and build a hobby grade version with things like probably a Maytech flight controller, foam plane, and kind of quadcopter motors, and see how well we can get that all to work. I'll see you next time. Thank you for spending your time today watching that video. You can find me in all the usual places on social media, and if you're trying to learn about a subject, then check out the playlist. All of my videos are organized into easy to follow playlists that, if you're trying to learn a topic, will take you from the basics right the way through to some pretty advanced stuff.